This is a live look at NASA's Space Launch System rocket and Orion spacecraft poised on Launch Pad 39B. Tonight, managers from across NASA met here at Kennedy Space Center to discuss if we're ready to fly to the moon. Good evening, and thank you so much for joining us live here at NASA's Kennedy Space Center. I'm Megan Cruz with NASA Communications. You are watching the Flight Readiness Review briefing for NASA's Artemis 1 mission. Liftoff of this first uncrewed flight test is currently targeted for Monday, August 29th at 8:33 a.m. Eastern Time from historic Launch Pad 39B. We have NASA leadership from around the agency to brief you on today's Flight Readiness Review that just wrapped up. First, we have Bob Cabana, NASA Associate Administrator. Janet Petro, Director of the Kennedy Space Center. Jim Free, Associate Administrator of Exploration Systems Development. Mike Serafin, Artemis 1 Mission Manager. Charlie Blackwell Thompson, Artemis 1 Launch Director. Howard Hugh, Manager of the Orion Program, and Chris Cienciola, Deputy Manager of the SLS Program. Thank you all for being here. So we're going to start with some opening remarks from each of our guests here, and then we'll take questions from reporters. So Bob, take it away.
Thanks, Megan. Well, first off, let me just say how great it is to be here after today's Flight Readiness Review. Jim did a great job leading the team through a lot of complex topics, and we are go for launch, which is absolutely outstanding. This day has been a long time coming. The review, as thorough as it was, in no way encompasses the amount of work that the team did to get us here, and I could not be more proud of our amazing NASA Civil Service contractor team that put that rocket out on the pad and is getting ready to launch it, hopefully in a week. You know, I do want to say that I want to put this in perspective. This is a test flight, all right? And it's not without risk. We have analyzed the risk as best we can, and we've mitigated it also as best we can. But we are stressing Orion beyond what it was actually designed for, in preparation for sending it to the moon with a crew. And we want to make sure that it works absolutely perfectly when we do that, and that we understand all the risks. We're going to learn a lot from this test flight. There are certain cases that could come up that could cause us to come home early, and that's okay. We have contingencies in place, and the main objective that we really want to get out of this test flight, of course, is that stressing that heat shield, getting a test of that new Orion heat shield at lunar reentry velocities. So I just want to say I'm really looking forward to this. We have worked really hard to get here. The team has done an absolutely outstanding job, and as difficult as it is, we're up to the challenge, and I'm really looking forward to a successful test flight.
Thank you, Bob. All right, Janet.
So good evening. It's really another great day at America's spaceport. You know, we move in one day closer to our launch. So last week at Kennedy Space Center, we held our Launch Center Readiness Review, and this is where we assessed all the systems to get us ready for launch, and that led us into today's Agency Readiness Review. And really appreciated the discussion at the agency review around this being a test flight and the risk we're taking as we stress the vehicle beyond what it would nominally be operated in future missions, particularly with crew. But I can tell you there's an energy and there's an excitement around the Kennedy Space Center, I would say, across the agency and all around the Space Coast as we get closer and closer to this launch. You know, ever since we rolled out to the pad last week, you can feel the excitement, the energy increase, and it's really, really palpable. Our teams does have some work to finish up at the pad, but we are very excited, and I can't tell you how proud I am personally of the team here at Kennedy Space Center and the integrated team across the agency, how hard they have worked for a decade to get to this point. And so we're ready. We are going, and go Artemis. Megan?
I like that I'm hearing we're ready from both of you. All right, Jim.
Yes, good evening, and thanks for letting me be here today. What a great moment we had today with the Flight Readiness Review. I got to be honest, pretty cool to chair a Flight Readiness Review. It's great to be part of this organization and lead the Exploration Systems Development and Mission Directorate with Kathy Kerner. That for our purpose, is to really look at our readiness from launch all the way through recovery. So really focused on launch right now, but we were talking about launch, flight, and recovery today. Bob mentioned it, incredible depth of work. We only really skimmed the surface, I'd say, of the work that's been done over the past number of years. Really staggering number of requirements and verifications the team has done that really are there to push the vehicle to the limits. Bob talked about the risk. We are pushing the vehicle to its limits, really stressing it to get ready for crew. It is incredibly risky. We talked about risks today. We talked about our mitigation steps for those risks. And we've mitigated the risk as far as we can, and now it's our time to get to launch so that we get that data that we need to put crew on it. I'm really proud of our folks that have put their time in, their families that have given up time with them, the dedication they've shown. I think that came through today. We know there's thousands of folks that supported that review that we had today, and I'm really grateful for their work. The results, we had no exceptions today. We actually had no actions coming out of the review, and we had no dissenting opinions today. We do have, as Janet mentioned, the work to go at the pad, which you'll hear about from folks that follow me. We did talk to the launch team, we talked to the flight team, we talked to the recovery team, and then the management team, and everybody said they're ready to go. So we're looking forward to the mission.
Jim, thank you. Mike.
Yeah, good evening. Getting your license to fly represents a significant milestone, and it's representative of the teamwork and the level of preparation that it takes to go to this point. The flight readiness review process is a thorough wire brushing. Is the rocket ready? Is the spacecraft ready? Are all the teams ready? And we went through all that today, and we talked about some open work, but those are largely things that we have a path to close before we go fly. In terms of the mission management team, which I'll be chairing when we get to pick up at the Launch Minus 2-day review, which is essentially our launch readiness review, we have a series of decision gates that are in front of us. And the purpose of the mission management team is to provide oversight and risk acceptance, as well as to basically, if we are outside of our pre-planned criteria, to assess whether we should continue or whether we should knock it off as part of a flight test. We do have a series of checkpoints built into the mission, and we've trained those alongside of our operations teams, our launch team, our flight team, and our recovery team, as well as with our engineering support elements in Huntsville and in Houston. The test flight itself carries inherent risk, and we talked about that today. We talked about what we call moderate risk and high risks throughout. This is the first flight of a new rocket and a new spacecraft, and at its furthest point, the spacecraft will be nearly 290,000 miles from Earth before returning home. And this is the first human-class mission in over 50 years. So we're doing something that is incredibly difficult to do and does carry inherent risk in it. I guess one thing that I've been reflecting on today was a quote by Hugh Dryden, who was one of the founders of the Apollo program, and he talked about the purpose of flight testing, which was to separate the real from the imagined and the known from the unknown. So that's what Artemis 1 is all about.
That's a great quote. Thank you, for us to keep in mind as we move forward. Charlie.
Well, good evening. It's great to be here today, 1 week away from launch. And it feels great finishing up the flight readiness review and knowing that we are one step closer to launch. Our teams here at Kennedy Space Center are finishing up our processing and working hard to get us to our call to stations, which is planned for Saturday morning. Since arriving at the pad, we rolled out in the evening on Tuesday, and after arriving at the pad Last Wednesday morning, we have been busy doing our validations of our critical facility connects to the mobile launcher. That includes all of our commodities, electrical connects, command and control, all of those are complete and behind us. And we are getting ready right now for our, what we call our program-specific engineering tests, which is we have about 2 tests left. That's one of them. That starts tonight on third shift, or this evening on third shift tomorrow. And then we'll also pick up with our booster servicing activities. We did that during wet dress, that activity before, and so we have a lot of experience with it. Those are our final 2 tests, and then we finish up our launch countdown preps and get into launch. So the teams are working really hard. We're on plan for that call to stations on Saturday. As has been mentioned in previous press briefings, we have extended the time frame of our flight termination system that is required by the Space Launch Delta 45th to cover 3 launch attempts. I wanted to mention that since that was a change since we met last time. And then also we have finished up all of our launch team training. We've completed 30 sims, so our team is certified and ready to go. So we are on plan and certainly looking forward to call the stations coming up on Saturday.
Charlie, thank you. Howard, next.
Yeah, good evening. Thank you, Megan. Let's see. Today is an exciting day for the program, culmination of a lot of hard work by many people and demonstrated today through our review and understanding of the risks and the mitigations that we have as a program. And so appreciate the time we spent today with senior leadership talking about those and really understand where we're headed with the mission. Charlie talked about her preparations. For Orion, we had a few items that we need to close out, specifically the payloads that are going on board the spacecraft, the dosimeters, the radiation hardware, the biology experiments. We were able to load all our hardware and, of course, our crew interface and technology demonstration, Callisto, was also installed and finalized. So all those payloads that we have inside the crew cabin are ready to go. And the hatch was closed today, so we're looking forward to the next steps. The next steps will be we'll finally open up the hatch one more time, install the final our zero-G gravity indicator, Snoopy, so that'll be really exciting as well. We'll do final closeouts where we'll pull the soft covers from the windows and the seats and things like that, and we'll be ready to fly. And of course, during the countdown or count up to the launch, we're going to be very excited to lift off, and I'll be looking at several things. Our team will be looking at the data, one of which will be, getting the service module ready for firing the main engines, what we call service module priming of the propulsion system. Service module is a big component of the overall Orion spacecraft. It does propel us. It gives us a lot of capability to have propulsive capability, number one, and it also provides active thermal and in all the water and ECLS hardware that we need to support crew. So it's a great demonstration. The European service module, which is part of the service module, is a very important component of the Orion program. Our European partners have done a great job of developing the European service module and getting us to this day. And of course, we're looking forward to our translunar injection. It's about an hour and a half after we launch. So really looking forward to getting to the moon, and thank you for your time today.
Thank you, Howard. And finally, Chris.
Okay, good. And I'm too excited to be here. And from the SLS team, our job is to get Orion to the TLI that Howard just spoke to, right, and get it into the intended orbit so it can go on to the moon. We convened with our leadership team. We had our contractor team, our element management team, our chief engineers here today to support us, to talk about our steps along the way to get here and our readiness to fly. When you talk about a test flight, you look at the build up to get to this point. We've gone through single engine test. Y'all followed the Green Run test series at Stennis. We've had full scale booster test, several structural tests that we've had of the vehicle and structural test articles in the dynamic rollout test that we had. So now it's time for the big test of all. It is the combined environments test and flight. It's a test that we can't duplicate on the ground. We've tried our best with all the environments we have, but this is the reason we fly, to fully understand the vehicle. So we're excited about it. At the end of the day, we went through all the polling. The team is ready. The rocket is ready, and we're here to support.
Thank you so much. Thank you for the opening remarks. And now, as promised, we're going to take some questions from reporters either here in the room or over the phone. Please introduce who you are and who you're affiliated with, and then also, just to get to as many of you as possible, ask one question and let us know who you'd like to answer that from the panel here. So we'll start with you over there.
Thanks. Irene Klautz with Aviation Week. I don't know if this is for Charlie or for Mike. Are there any restrictions on the SpaceX's use of 39A once the countdown begins?
You want to take that or wait?
You take first crack.
All right, so I'll start off, Irene. So with regards to restrictions at 39A, when we get ready to go into tanking and we establish our BDA, our blast danger area, and our launch danger area clears, certainly that will impact work over at 39A.
So not until tanking begins, as far as the countdown starting Saturday?
Just prior to that, certainly the access to 39A is available.
Okay. Thank you. Over here.
Hi guys, Bill Harwood, CBS. This is for Mike Seraphin. I am still a little bit confused without an abort motor in the LAS. Could you explain the abort scenarios for this flight? I mean, I guess you can get off after 3 minutes in, 16 seconds or something, but I'm unclear about what happens when you're overflying Africa or where abort once around comes into play. I don't understand the timing of those things. I mean, I hope it never happened, of course, but just so we understand it if it actually did happen.
Yeah, I agree with you 100%, Bill. We hope that we don't need those capabilities, but we've inherently designed in abort capability to protect crew on later flights. On this initial uncrewed test flight, we do not have an active abort motor on the launch abort system. We have an active jettison motor. Normally we don't need the abort motor. It would only be required in the event that you're trying to protect the crew. Up to the point where you achieve what's called untargeted abort splashdown. So you're about 3 minutes in the flight, closer to 4 minutes in the flight, you have to separate the service module fairing panels, and then at that point you can use the service module for aborts, and it's at that point, once the service module fairings separate, and we verified that we can use the launch abort, or we can jettison the launch abort system, and that provides what's called untargeted abort splashdown capability. So the vehicle at that point could splash down anywhere in the Atlantic before we get to the African continent. Before the untargeted abort splashdown coverage ends, we actually pick up abort once around coverage, so we actually have overlapping abort capability, and we could abort once around if necessary. And then if we don't need to abort once around, we would proceed through perigee raise and either enter a low Earth orbit or proceed through the point of translunar injection. And Howard, I don't know if you have anything to add to that. It's the Orion spacecraft that we're talking here.
Yeah, no, Mike, I think you covered it very well. Certainly we have that overlap capability. I think that's very important. And if we have that energy, we'll be able to go do abort once around and come back and try a nominal landing.
Thank you for that question. We'll take two on the phone now. We have Chris Davenport with the Washington Post.
Hi, thanks so much for doing this. I guess this question's for whoever wants to take it, but a couple of the panelists said that this mission is going to stress Orion past what it was originally designed for when it has crew on board. I wonder if you could just elaborate on that. Are you talking about the long duration of this test flight, or the fact that you'll be going some 40,000 miles beyond the moon, or is it some other challenge? Thanks.
Yeah, maybe I'll start. Certainly, I think you touched on that's one of the key things that we're stressing. 21 days, active days with 4 crew. That's one of our key design parameters. But certainly, this mission allows us to push a lot of capability. Certainly, duration, the long class mission that we're talking about, 42 days, will allow us to stress a lot of the systems and be able to check out those systems. So that would be one of the bigger drivers for the program. And the heat shield will have the same return velocity. I think you asked about the heat shield. So certainly the demonstration at 25,000 miles per hour coming back is very important because those will be our lunar return trajectories with the crew, and that'll demonstrate our capability and really validate the models and the ground testing we've done with the heat shield, and that'll be a good demonstration of that capability in the real-time environment.
Great. Also on the phone is Kristen Fisher with CNN.
Thank you very much. This question is for Bob Cabana. It's been about half a century since NASA has had a rocket designed to take humans to the moon on the launch pad, ready to actually launch. I know it may not be, historically speaking, the right stuff for astronauts and former astronauts to talk about their feelings, but I'm curious, Bob, what it feels like to be working for NASA at this moment in history, a week before launch, with all that's gone into this.
Feels pretty outstanding, Kristen. This has been a long time coming. I think I've shared with all of you, I had the privilege of seeing an Apollo launch. I saw Apollo 13 launch as a young midshipman, and I never dreamed I'd end up being an astronaut, let alone director of the Kennedy Space Center or in the position I'm in now. And worked really hard the years I was at KSC getting ready for this, and Janet has got to take it to its completion, seeing it roll out to the pad for launch. But I have to say I'm really excited and honored to be in the position I am, to actually be part of seeing SLS, Artemis 1, out there on the pad, launching us, returning us back to the moon and eventually on to Mars. I'm a product of the Apollo generation, and look what it did for us. And I cannot wait to see what comes from the Artemis generation, because I think it's going to inspire even more than Apollo did. It's going to be absolutely outstanding. I also want to throw in, the administrator and I both sat through that entire review today, and Pam was dialed in on it from Washington, and a lot of work to get to this point. So I think that's one of the things that I feel when you ask how do I feel amazing pride in the team that got us to where we are, and it was really outstanding. It was rewarding to be able to see all that work during the review today and know that we are ready to go do this.
Well said, Bob. Thank you. We'll go to some questions here in the room. Go ahead.
Hi, I'm Jim Siegel. I'm with NASATech.net. A question for Bob Cabana. You mentioned, Bob, the importance of testing out the heat shield. Perhaps that's the most important aspect of this flight. And I'm curious about whether during the flight, if there are any tests or checks on that heat shield before it actually goes into practice during reentry. Anything going on during the test?
That's a great question, Jim. And I'm going to turn that over to Howard, because Howard owns that vehicle. That is a highly instrumented heat shield. We're going to be monitoring it throughout the flight and reentry. And Howard, any checks that you got planned during the mission itself?
Yeah, not specific. Obviously, the crew module and the service module are attached together, so we're not. It's unlike we're in an orbiter. Where you going uphill and separating from the core stage, you've got potential impacts or anything like that. So there's no unique tests about it. Certainly instrumentation-wise, we have a lot of hundreds of instrumentation on the crew on the heat shield for the crew module, and we'll be able to collect that data and of course review that data when we get back the crew module.
But that's before reentry. That instrumentation.
The instrumentation that already exists on the vehicle itself, and then as part of reentry, it'll be collecting the data.
Mm-hmm. Thank you.
You bet.
All right, we actually have some other questions on the phone. We have David Curley with the Discovery Channel. David.
Thanks very much for taking the question. It could be Cabana free, Seraphin, but I think Howard, the question from Davenport was, stressing this vehicle beyond, we know about the heat shield. What I heard from your answer is just duration. Are there other things that you are stressing the vehicle beyond duration of the mission?
David, since it was my comment that started this, I'll say a few words and I'll turn over to Howard and Mike. But as Howard mentioned, it was designed for 21 days, and that's what the European service module was certified for. going 42 days puts a lot more stress on all those systems, plus the environment that it's in. Longer exposure to radiation, longer exposure to micrometeorite hits. We're going to learn a lot from this test flight. And the point is, we're stressing it beyond what it was designed for, and we'll see what we learn. Anything you want to add to that, Howard?
Yeah, I think you hit really good points. You know, from a fundamental perspective, you know, when you stretch out the duration, the environment that you're going through on the 1.5 revs that we're going to go through on the DRO, that'll allow you to test out the systems fully as you go through that time frame of 42 days. And so that duration, along with, you know, we're really trying to activate all the systems utilized. For example, optical nav. We're pushing the optical nav technology and be able to certify that for future flights when we don't have comm on the spacecraft potentially, and utilizing that as a navigation asset. So those are things that we're looking forward to in terms of demonstrating capability and pushing the envelope of the technologies that we have on board the spacecraft.
We'll take another one on the phone. Ramin Skiba with Wired Magazine. Ramin, you there?
Yes, I'm here. Thank you. I just wanted to ask a question. I think this might be for John Honeycutt or Mike Serafin. I'm wondering, could you say a little more, like under what scenario, like, would you abort? Are there certain things you're watching out for where it could, end the mission a little earlier, basically?
Yeah.
Go ahead,
I'll
Mike.
take a crack at that one, Chris, and then you can add anything you want. So on Artemis 1, we have a lean forward strategy to get our high priority objective, which is to demonstrate the heat shield at lunar reentry conditions. We are going to press to the point of translunar injection unless we're sure that we're going to lose the vehicle. So we've got a lean forward strategy here on this flight. We would be go on this flight for conditions that we would normally be no-go for on a crewed flight in the interest of crew safety. But because we want to buy down risk across the manifest and to understand this system and the system design and its margins, we are going to press through the point of translunar injection if at all possible. In terms of aborts, the vehicle is largely automated from the point of booster ignition all the way up through translunar injection, and we've got go no go criteria that have been established at various points along the way, including the translunar injection maneuver, and then we have a couple of gates prior to the translunar injection maneuver as well as prior to the perigee raise maneuver, and we could punch off the interim cryo propulsion stage while it's in a inhibited attitude control system phase. Those bars are set pretty high. We would only do that if, again, we were pretty sure we would lose the work. So that is something that is unique to this uncrewed flight test, and we're going to press ahead and press uphill unless we're sure we're going to lose it. I don't know, Chris, if you have anything to add on that.
No, I'd just say that we're preparing to fly a nominal mission, right? And if for some reason the rocket's not performing as planned, there's options based on what's happening and when it happens, right? So that's what Mike was referring to.
We'll go back to the room here, and then we have several on the phone again.
Thanks. Stephen Clark from Spaceflight Now. I think my question's for probably Mike Serafin. Listened to your webinar last week about launch windows and the trajectory for Artemis 1. One thing I'm still not clear on is you talked about the variable azimuth during the 2-hour window. Is that trajectory calculated on the fly basically by the SLS guidance system, or is it calculated like minute by minute or certain intervals on the ground and then uploaded into the computer? Just how does that work as you navigate to get to that target for TLI?
The short answer is yes, the SLS calculates that based on the time of liftoff, trying to hit the insertion altitude, which is a 975 by 16 nautical mile insertion altitude, and then the upper stage, the interim cryo propulsion stage, adjusts to account for the differences in the point of translunar injection. So you got to remember the Earth is rotating on its axis, and as we wait throughout the 2-hour window, the launch site is going to be in a different position with respect to the point of translunar injection in the moon. So we're accounting for that through onboard guidance calculations and the variable azimuth is really trying to set up what we call the antipode, or the point opposite, relative to the moon, to set up that intercept point. And when you've got this three-body dynamic, you got the Earth rotating on its axis, the moon going about the Earth, and the spacecraft launching over up to a 2-hour window. You've got to take that into account.
Okay, we'd like to go on the phones. Who's next on the phone we have here? We have Jeff Faust with Space News.
Good evening. A question for Mike Serafin. You mentioned you had some open work left to do, and I just wanted to see if you could provide any more details on that open work, and if that is work that you would normally expect to be open at this point in launch preparations, or if it's something that is not expected but you still expect to close in time for launch next week. Thanks.
Yes, some of the work is very straightforward, very simple, like what Charlie outlined, to load the boosters with their fuel and to get the vehicle configured. Probably the biggest one that was talked at our flight readiness review today was the hydrogen kickstart to thermally condition the engines. If you recall, coming out of the last wet dress rehearsal, that was the one open item that we had, and that is the one open item that we have headed into this launch countdown. And Charlie and her team have come up with a plan to demonstrate it before we get into terminal count. And that is something that we're going to demonstrate end-to-end for the first time on day of launch. And if we do not successfully demonstrate that, we are not going to launch that day. And I don't know, Charlie, if you have anything to add on the hydrogen kickstart.
No, I think you covered the hydrogen kickstart. We did, what we'll do is we'll plan to put that in after we get core stage LH2 or liquid hydrogen into replenish. And we'll close the vent valve on the core stage. That puts some pressure on it. We'll go and verify. First off, we'll verify the functionality of that 4-inch QD where we had the issue during wet dress rehearsal, verify that that's working correctly. Once we have a predetermined amount of kickstart bleed, it's about 45 minutes or so, and then we'll get into a vented bleed, and then after that we'll do the special pre-press test. Normally that would happen in terminal count. We would have done it in wet dress, but we weren't able to do that because of the issue that we had, and so we've added that into the launch countdown at a kind of a quiescent point, if you will, so that we can understand that prior to getting into terminal count, where you have a lot of other dynamics in your system. And then with regard to other open work, I would just say from a pad flow perspective, we are really down to those 2 tests we talked about. We'll get into those tomorrow. One is we'll go through and we'll do our safe and arm rotations. We have already completed, Howard talked about the late stow work that we did this weekend, the Orion hatch closure, and so that's behind us. So now really we're just looking at that RF testing, the safe and arm rotations, the booster servicing, and then getting into our launch countdown preps, and then into launch countdown proper. But all of that work is very, very well choreographed, laid out, and again, very consistent schedules with what we had going into wet dress.
Thank you, Charlie and Mike. Also on the phone, we have Micah Maidenberg with Wall Street Journal.
Hi there. Maybe this one goes to Bob Cabana or Jim Free. Could you describe kind of the minimum milestones that NASA needs to reach with Artemis 1, to keep pressing on toward Artemis 2? Like, how does the agency know, that it's ready to really focus in on Artemis 2 after this launch? Thanks.
Thanks. I'm going to turn that over to Jim. He's in charge.
Thanks, Bob. I think you've heard on some of the other calls about the objectives that we're working, the heat shield, the stressing the system, the delivery and performance of SLS and recovery of the vehicle are all critical things we need to do before we can talk about going to Artemis 2. If we don't get all of those, we'll have a discussion about the risk that remains before we would put crew onto Artemis 2. The other thing I want to stress is we're going to learn a lot on this mission. You've heard about risk here, you've heard about aborts, you've heard about flying longer. We're going to learn a lot about how this vehicle works. And there's going to be things we have to do to the Artemis 2 capsule, service module, SLS, that will have to be done before we go on to Artemis 2. So Well, I think someone said it in the FRR today. We want to make sure we understand that before we just run for Artemis 2. So we have to take both into account. We need to keep on track for Artemis 2, but we need to understand what we learn on this mission. That's why it's a test flight. But our focus are those basic objectives.
Tariq Malik with Space.com is on the phone. Can you hear us?
Yes, I can hear you, and thank you so much. That's Hard Knowledge at Space.com. I think my question is for Charlie Blackwell-Thompson, the launch day itself. Charlie, we've had a few wet dress run-throughs, but not down to that T-9, T-0 that was sought at that time. And I'm wondering what is left unknown that you're looking for that might be stopping points or things of concern that you just don't know how the booster is going to work yet to make that decision for launch there. And I'm just curious about kind of what the process would be to kind of go through that launch or call a hold for the window if it's needed. Thank you.
So let's see. I think your question was about different hold points and maybe things that we didn't get as part of wet dress. And so the biggest thing we didn't get during wet dress was the verification of that bleed in the 4-inch QD. So we're certainly looking forward to testing that out. We believe that we have taken all of the actions to correct that problem, but of course we can only test it at ambient conditions in the vehicle assembly building. And so when we hit it with cryos at the pad during that bleed kickstart is when we'll know that we've got that problem fully behind us. So I would say that's one area. We already talked about the pre-press test. And then, of course, during wet dress, we got down to T-minus 29 seconds. And so, we're looking forward to getting those last 29 seconds off the countdown clock. And there's a lot of dynamics that happen as you get down close to engine start. So, there's certainly still things that you don't get. Even had we gotten down to the 9.34 seconds that we planned for wet dress, there would still be some functions as part of either the ground launch sequencer or part of the software and the vehicle configuration that we would not have gotten, but from wet dress to launch.
And we'll stay on the phones with Marcia Smith with SpacePolicyOnline.com.
Thanks so much. I think this question is for Chris. I'm wondering if you could just explain or describe the disposal of the core stage. I understand it's going to come down somewhere between Hawaii and San Diego. Is that right? How actually do you dispose of the core stage? Do you tumble it the way you did with the external tank and it disintegrates into pieces, or does it all come down in one piece? What exactly happens to it?
It will break up at altitude and come down over an area. So there's different footprints based on the exact time of launch, right, and when we go up. So you're talking about like what we used to do about the external tank with the tumble valve and all. We don't have that feature. The vehicle will break up on its own as it comes back in.
Okay. We'll take two more on the phone. We have Robert Perlman with Collect Space.
Hi, thanks. For Mike Seraphin, maybe Howard and Chris, can you share to what extent, if at all, you have additional confidence that SLS and Orion are ready to fly, given that some of its propulsion elements have already been used on multiple shuttle missions, as opposed to if they had been new designs or never flown before?
Well, I'll start from SLS, Howard, and then hand it over to you. Relative to, we reuse engines, right? We're reusing engines here from shuttle, but the engines, for example, have new controller systems on them. So the engines we have on Artemis 1, each have gone through a full-scale, full duration static test as a single engine. After that, on Artemis 1, on this very vehicle, it went through the full-scale green run for a full mission. So obviously this one's been rung out pretty good, right, with space shuttle experience and ground tests. When we get to Artemis 5, we'll be bringing on engines that do not have the flight experience. We will get that data through ground tests, and we'll test each engine individually with the controller that it'll fly with. So that's how I would answer the SLS. Now, on the booster side, the components, obviously it's just the case segments that are reused in some of the structure. When that hardware is expended, we will have new hardware. Each of those pieces of hardware goes through an acceptance test and a pressure test individually. So they will also get rung out prior to casting. So that's the answer for the launch vehicle side, and you may want to touch on Orion.
Yeah, thanks, Chris. If you don't know, our reuse of the OMS E, or the Shuttle Orbital Maneuvering System engine, is our main engine. It's our only engine that is actually from the shuttle program. The rest of the engines are Plus X, or auxiliary engines, and then our RCS engines on the service module are brand new, and as well as our RCS system on the crew module. So we've done not only replacement of the soft goods that comes with the OMS E engine that we got from the orbiter program, or the shuttle program, and we've done a lot of extensive testing. We've recertified them, and we tested as a system together in our qualification at White Sands Test Facility. So all those tests have demonstrated that capability. And of course, that's why we're going to exercise. One of the things we're going to do very early after our TLI burn is we're going to exercise the OMS engine. And it's not necessary for a correction maneuver, but we're going to exercise that main engine to make sure that things are operating as we can. So this is a demonstration, like Jim and Bob were saying earlier. You know, we're demonstrating a lot of capabilities that we're going to need long term. And this is one of these things that we're going to be flying for a little while in the next few missions of other orbiter engines. And so this will be a very good characterization of the performance and our ability to utilize that main engine.
Yeah, Robert, probably the only thing I would add is while we have tested each of these subsystems, whether they're the boosters, the RS-25 engines, the Orion main engine, and the auxiliary engines, on the ground, it is the first time we're going to operate these together as one integrated vehicle. We could learn some things, as Jim said. We are going to learn about the vehicle as a whole. Some of it could be as simple as where we have software limits or software triggers. Maybe we were a little too conservative, or maybe we had a little less margin than we anticipated, and we will definitely learn from this test flight. But a lot of the work has already been done in terms of workmanship checks and quality checks, as well as ground testing.
One more on the phone, and then we'll come back into the room for some follow-up questions here. We have Christopher from Astronomy Magazine.
Yes, hi. Chris Coquinos from Astronomy Magazine. Thank you, and good luck, everybody, for next week. My question is, I think probably for Mike. Jake Bleacher was talking about the CubeSats last week, and some of them can be recharged, some can't. So I'm just curious, the ones that cannot be recharged on the ground or can be recharged somehow in space, are they going to make it past these first 3 launch windows through early September? If they don't, are they just a loss? And is that something to address in the future, to have only CubeSats that have some charging capacity on the ground? Thank you.
Yeah, Christopher, that's a good question. Yes, we have 10 CubeSats on this flight. We talked at the flight readiness review today. 5 of those have been essentially topped off in terms of battery state of charge. We've had open communications with each of the CubeSat customers as to access and just design constraints all the way up through the install on the vehicle. Prior to that, we had the payload safety review process, and we are at the point where we're getting ready to fly. The remainder of those CubeSats, we, based on analysis, believe have sufficient charge to conduct a mission. Some may actually need to recharge after they're deployed, after they gain some solar power through their solar arrays, but we believe each of these has a mission. That said, the CubeSats are relatively low cost. They have relatively low levels of redundancy and a relatively high failure rate. So we do anticipate one or more of these CubeSats to not be successful in its mission, just due to the nature of the CubeSats themselves.
Irene, you in the room?
Irene Klotz with Aviation Week. I two questions. Bob, in your opening comments, you mentioned about a possible early return of Orion. Is there any, and I don't know if this is for you or Howard or someone else, but is there any scenario where Orion could return early, but you'd still be able to fulfill the reentry heating conditions that you're looking for? And the other question just is about the pushing Orion. You mentioned the TLI burn and how you'll be accepting some conditions for uncrewed Orion versus crewed. Could you please provide maybe two specific examples of where you'd go for TLI burn on an uncrewed Orion versus crewed? Thanks.
So I'm going to turn it to Howard for the details, but there are cases where we would not do the full mission in that distant retrograde orbit. We would still circle the moon and get the heat shield data on reentry, and it depends on, the health of all the systems on the vehicle. But Howard, you want to answer that and the other question also?
I think what you're, Bob's pushing on is if we can commit to TLI, and I think that's what Mike was talking about where we're leaning forward is if we can press the TLI, that'll give us a lot of capability to have alternate missions where we could get that lunar reentry speeds. And I'll turn to Mike to talk about a couple things that he would push for in terms of moving forward on TLI.
Yeah, Irene, that's a great question. We've put considerable planning and effort into what we call alternate missions, and we're going to go as high as we're able to within the consumables and the systems that we have. If we have a performance problem on the rocket, we're going to fly as far as we can, and there are cases where we can try to make some of that up with either the intercrowd propulsion stage, the upper stage, if there's a core stage performance issue. And then there are other cases where we may be able to complete the translunar injection maneuver using the Orion spacecraft and its service module. So from an integrated performance standpoint, there are scenarios where we'll fly as high as we can. If we are uncomfortable for whatever reason, performance or systems-wise, with entering the distant retrograde orbit, we have alternate missions that would allow us to down mode to a lunar flyby. At translunar injection, we are not targeting a free return trajectory, but we could adjust to down mode to a free return trajectory about the moon. And then if we didn't have enough performance to do a lunar flyby, we could do a very high elliptical orbit and go out as far as we could towards the moon and come home. Or we could do a high Earth orbit, or we could do a low Earth orbit. So depending on the performance margin available and depending on the systems problem, we could fly as high as we could, and that's part of our alternate mission strategy. In terms of pushing Orion, one of the cases that we've talked about is a failed solar array deploy. If you look at our timeline, we normally separate from the core stage, we deploy the solar arrays, we do the perigee raise maneuver, and then the translunar injection maneuver. If we had a failed solar array deploy, we would proceed. And that is something that we wouldn't necessarily do on a crewed flight. There are a number of other systems that we've agreed to proceed forward with, and we could be zero fault tolerant. We could be on the last remaining string of our guidance and nav system, on our propulsion system, on a whole host of other systems, and we would proceed through TLI.
And the point I wanted to make, Irene, was that this is a test flight. It is the first flight of a new vehicle. It is not without risk. And there are things that wouldn't necessarily go exactly right. Hopefully it's going to all go perfectly. But Mike and his team have done an absolutely outstanding job looking at all the things that could possibly go wrong and looking for contingency plans that still get us the maximum amount of data. So.
Phil, you have a question?
I do, but he was in.
Oh, Stephen. You
can...
Go ahead, Stephen.
Yeah, I have a couple of questions. First of all, we talked about risk. Can you share the loss of mission probability calculation for Artemis 1? And then I have one more as well.
Loss of mission. The number is rattling around in my head, but I don't want to be quoted saying the wrong number, so I don't remember what it is off the top of my head. We could get you that after the fact. I don't know if anybody else has it.
Okay, another question was, I think we had this discussion during the WDR campaign about the launch countdown audio. And at that point, you had said that the audio from the countdown would be reviewed for export control and be approved for release to a certain point. I think you've approved that, it seems like, starting at L-15 minutes. And I'm curious, Was that review completed, and is that when the export control people basically told you that's when we can share the audio? And then secondly, and related, have you sought an export control license or an exception or exemption from the State Department for any video or audio associated with this countdown?
I'll start with your last question. We haven't sought a license. We have folks who are export control reps that we rely on to understand the regulations that we have and do the right thing. So let me say that up front. Now, having said that, it's been a fascinating process trying to make sure that we share as much as we can. Our Office of International and Intergovernmental Affairs is the one, or Interagency Relations is the one who really owns the export control side of it. So we've been working with them to get more of the count aired. We're trying to air everything through terminal count with someone sitting there to make sure to keep us in check. But we've pushed it that far. Catherine Hamilton continues to try and push to air more. So we are making progress, and hopefully you'll see that improvement for 1, and we'll continue to push for 2. We've done that by working back through the tapes that we have of all the loops. So once you get past Charlie's launch director loop, right, we start really talking some details. And what we don't want to do is that's what the team is used to right now. If you think of the NTD kind of loop, right, we're working a lot of details on that loop, and we don't want the team to start holding back talking things on that loop. So that's why we're trying to keep it at Charlie's loop. But for 2, we're going to look at what can we do to share even more. And I think there's folks in the audience that can tell you that that I work with that there's probably nobody pushing it more than me. So it's a work in progress. I think you'll see an improvement for launch.
Go ahead, Bill.
Yeah, this is for Charlie. Could I back up to your, I'm trying to understand when I should be paying attention for Daryl, since we might not have the loop, to tell me that the kickstart, the valve works. I mean, you've added a test to confirm it, but where does that occur in the countdown in either your L- or T- time, just so people know what's going on?
Yep. Well, we will start the kickstart right after we get core stage to replenish, and I'll get you an exact time for that. It's roughly a couple of hours before we get to T0. We will go through the kickstart. Again, that's about 45 minutes or so, and then we have the vented bleed that's going to take some more time. Now, when we get through all of that testing for that special pre-press test, that'll be prior to the T-minus 10-minute hold, when we get through that whole test that we intend to put in there.
Right. So replenish is where you start exercising it.
That is correct.
But wouldn't that have always been the case? In other words, I'm trying to understand how you learn in advance that it's tight. Is it that same point, or is there a special test?
It is that same point where we would do the kickstart bleed. The difference in the pre-press test, or the addition of the pre-press test, is after we get through the kickstart and then the vented bleed, then we'll go through and do a special pre-press test like we would do in terminal count, where we're actually pressurizing the tank. So that's the difference. That the team will take some time to analyze that data, and we'll get that back just prior to the T-minus 10-minute hold.
Okay, and the last one here in the room.
Jim Siegel again. I think this is for Mike. Maybe I missed it, but are any of the flybys going to be looking at the locations that were identified the other day?
I assume you're referring to the Artemis 3 landing site options that were released. Those are all within 6 degrees of the lunar south pole, and we will be largely in the Earth-Moon plane, so largely an equatorial flyby. So we will not have a direct look at the 13 sites. That said, we do have a considerable amount of data from one of the science missions, the Lunar Reconnaissance Orbiter, to help inform that. So we have, again, considerable information about the landing sites that were released. We just won't get a direct look during this flight, just due to the nature of the mission profile and the trajectory that we're flying.
All right, thank you so much. That's going to wrap up today's briefing. Thank you to all the questions that were asked and all the answers. We really appreciate your time, especially those here on the dais who've been here all day for the FRR. To continue following the mission when we're not doing briefings like this one, we're going to pull up a website and some social media channels that you can follow. You can see them right there on the bottom of your screen now. Again, launch of this uncrewed flight test is targeted for Monday, August 29th. That's less than a week from now. The 2-hour launch window opens at 8:33 a.m. Eastern Time, and our live coverage here on NASA TV and on our streaming channels will begin at 6:30 a.m. We hope to see you then. Good night.